Welcome back to the RPG Framework series. In the next few episodes, we're taking a major step forward by introducing one of the core pillars of any modern role-playing game, the skill tree system. This isn't just another menu feature. It's a fully modular, data-driven progression framework designed to work seamlessly with the gameplay ability system, giving players meaningful choices and designers ultimate flexibility. We'll start by building the foundation, the RPG skill tree component. This component will handle everything from skill nodes and unlock logic to save data synchronization. Each node will store metadata like prerequisites, costs, and ability references, all tightly integrated with gameplay ability systems so that unlocking a skill instantly empowers your character with new abilities. You'll also learn how to expose these systems through clean APIs, making it easy to connect your UI. Next, we'll dive into custom unlock conditions, a system built entirely for designers. You'll create blueprint-based unlock rules without ever touching C++. Want a skill that unlocks after mastering a weapon type, spending points in a specific branch, or reaching a certain reputation level? You'll be able to do all of that, and more, with just a few clicks. Finally, we'll supercharge the workflow with the Skill Tree Generator utility, an editor tool that automatically creates skill tree widgets from your configuration data. Linear trees, radial layouts, or complex branching structures, all generated and linked to gameplay data in seconds. Think of it as your personal assistant for building AAA quality skill trees directly inside Unreal. By the end of this mini-series, you'll have a complete, production-ready skill tree system that's flexible, expandable, and designer-friendly, a cornerstone feature for any RPG built on Unreal Engine. In today's video, we'll start by setting up the foundation for our skill tree system. To make this tutorial easier to follow, I've prepared all the C++ code changes for you. You can download them from the link in the description. Open your project in Visual Studio and find your project's build configuration script. Update your public and private dependency modules as shown in the video. Now go to the Unreal Editor and create a new subclass of the Gameplay Ability class. Name it RPG Skill Tree Gameplay Ability and save it in the Skill Tree folder. First, make this class abstract and blueprintable. Then, copy all the properties from the C++ source files. Here you can see that we're extending the default gameplay ability with all the properties that a skill tree ability needs. To better understand the purpose of each property, you should read the comments. In addition to the properties, we've also defined a constructor. Let's implement it. It should simply assign default values to some of the properties. Now go back to the Unreal Editor. Create a new C++ class. This time, use Developer Settings as the parent class. Name it RPG Skill Tree Developer Setting and save it in the Skill Tree folder. The purpose of this class is to allow game developers to set a default location for discovering skill tree abilities inside the editor section of the project settings. You'll see how we'll use it shortly. Go back to the Unreal Editor and add one more class. This time, select Game Instance Subsystem as the parent class. Name it RPG Skill Tree Subsystem and save it in the Skill Tree folder. We'll use this subsystem to initially discover and cache all skill tree ability assets when the game starts. Depending on your project's structure and size, this can be an expensive and time-consuming operation. That's why we'll use a Game Instance Subsystem, since it's executed only once per game instance. The most important part here is the Discover Abilities method. Here you can see that we'll use the Asset Registry module to load all blueprints from a pre-configured location. This is the location we'll read from the skill tree developer settings we created earlier. Finally, we'll check if the blueprint is a child of our skill tree gameplay ability and add it to the abilities list. Now go back to the Unreal Editor and create a new C++ class of type Save Game. Name it RPG Skill Tree Save Game. This class will be used to persist skill tree data between game sessions. First, we need to define a structure that efficiently holds unlocked abilities. For that purpose, it's enough to save the asset tags and the level of each unlocked ability. In addition to the unlocked ability structure, we also need to save the skill points earned during gameplay. Go to the Unreal editor once more and create a C++ class of type actor component. Name it RPG Skill Tree Component and save it in the Skill Tree folder. First, make this component blueprintable so we can inherit from it in blueprints later. Remove the tick component override since we won't need it. Now you can copy and paste the code from the C++ source file. Here you can see that we're defining all the necessary methods for handling skill tree logic. Let's start implementing and explaining them one by one. First, make sure to update the skill tree component constructor to initialize its properties. Now let's implement the unlockability method. Here, you can see that we first ensure that the input tags are valid, that the ability with the provided tags exists, and that the ability system component is valid. After that, we check if all prerequisites for unlocking this ability are satisfied. Then we verify if there are enough skill points to unlock the ability. Finally, after all checks are done, we can unlock the ability, grant it to the ability system component, and save it to disk. Let's move to the canUnlockAbility method. The implementation is simple. We just need to ensure the ability isn't already at its max level. Additionally, we verify that at least one of the prerequisite abilities is unlocked. The canUnlockAbility with tags method is just a wrapper around the previous one. Next method is getAbilityLevel. Here, we use the ability system component to check if the ability is granted and what its current level is. An important thing to note is that we completely rely on the ability system component to check the status of unlocked abilities. We can do that because we grant the ability immediately upon unlocking it. Let's move to the isAbilityUnlocked method. Again, we'll use the ability system component to check if the ability is granted. The next two methods are for getting and adding skill tree points. They're straightforward to implement. Next method is findAbility. This is the one that gets called frequently from other methods. The onAbility unlocked event is blueprint implementable, so we'll skip it. Next method is save data. We'll use it to save game data to a pre-configured slot. The data we need to save includes skill points earned and unlocked abilities. To find unlocked abilities, we'll iterate through all abilities in the gameplay ability system where the source object is the skill tree component. Next method is load data. Here we do the opposite, loading data from the save slot. After loading the unlocked abilities, we need to grant them back to the ability system component. Next method is load skill tree abilities. This method caches references to all available skill tree abilities. This is where we'll use our skill tree subsystem. Load skill tree abilities is called inside the component's begin play method, which is why it's important to use a Game Instance Subsystem instead of accessing the asset registry directly. Notice that during the begin play method, we also set a reference to the ability system component from the owner. The next method is find ability. This is similar to the one we implemented earlier, except this one uses a single gameplay tag to search for the ability. The last method is grant ability. In the implementation, we need to ensure that the ability system component is valid. Then we handle the case where the ability is already unlocked and its level is being upgraded. Lastly, we auto-activate passive abilities. This ensures that passive abilities activate immediately upon unlocking. Finally, save all the files, close the Unreal Editor, and build the project in Visual Studio. Once the build is done, open the Unreal Editor again. First, let's look at the purpose of the skill tree developer settings. Open Project Settings and navigate to the Editor section. Here, you should see the skill tree settings. This is where you set the path to the root folder that contains your skill tree abilities. I'll leave the default value for now. Now, create a skill tree subfolder inside the Blueprints folder. Create an actor component as a child of the RPG skill tree component. Now find your player blueprint and add the skill tree blueprint component to it. In the Details panel, you can see all the available skill tree settings. Let's start integrating the player and skill tree component by adding skill points when the character levels up. To keep the player and skill tree component independent, I won't call the Add Skill Points method directly from the player blueprint. Instead, I'll use gameplay events. At the end of the on-character level up event, send a gameplay event to the player actor. This gameplay event should carry the new character level inside the event magnitude. Now go back to the skill tree component blueprint. On the Begin Play event, add a function that waits for the character level up gameplay event. To make this configurable, I'll promote the event tag to a variable and make it instance editable, so actors using this component can change its value. Make sure that only Match Exact is selected. When the level up event is received, we'll call a new custom event in the skill tree component. I'll name it on character level up and add one input parameter to accept the new level. To handle how many skill points are added per level, we'll use a curve table. This gives us a data-driven skill points system that allows different amounts of points based on character level and is easy to modify. Additionally, I'll make the curve table handler variable instance editable so the skill tree curve can be selected for each actor. For testing purposes, I'll assign a debug key for adding skill points. To keep this blueprint clean, you can place these two variables under the RPG skill tree category. I'll also print a message after skill points are added. Now let's test adding skill points. First, I'll add skill points using the debug key I assigned. You'll see a message confirming that the points were added. I'll also check that skill points are added when the character levels up. You may notice that the number of skill points added when my character reached level 6 is 2, just as I configured in the skill tree curve table. To track available skill points, I'll print them on screen when a debug key is pressed. Let's run the game again and check if the skill points from the previous session are persisted. As you can see, all the skill points earned during the previous run are saved and loaded correctly. If I keep adding new points, they appear immediately. Now that we have skill points, let's implement the logic for unlocking abilities using them. If you recall from our C++ implementation, we left the onAbility unlocked event to be implemented in blueprints. Let's do that now. Simply create a new event dispatcher that accepts the unlocked ability and the new level, and call it. For testing purposes, I'll print a message afterward. To unlock abilities, I'll use the input action use item we created during the inventory tutorials for consuming items. Now I'll create some test abilities and test UI widgets to verify that unlocking works. Later, I'll make a separate tutorial focused on the skill tree user interface. I'll create two abilities of type RPG skill tree gameplay ability and fill in their properties. Additionally, I'll make the second ability passive to test if passive activation works when unlocking. Also, I'll make the second ability require the first one as a prerequisite. To integrate the skill tree into our existing menu structure, I'll create some simple widgets. Finally, let's test the unlocking functionality. Run the game and check which abilities are granted to the player. You can do this using the Gameplay Ability Debugger UI. Open it by pressing the apostrophe key on your keyboard followed by the 3 key on the numpad. Notice that there are no skill tree abilities granted. Now open the skill tree menu. Hover over the first skill and unlock it by pressing the key assigned to the use item input action. Close the menu and open the gas debugger. You can see that the ability we just unlocked is now granted to the player. Now unlock the second ability. You can see that the second ability is granted and automatically activated because it's set as a passive ability. Now let's check how upgrading ability levels works. Go to the second ability and set its maximum level to 3. Run the game and explore the abilities. You should see that the abilities we unlocked in the previous run are still available, confirming that the save system works correctly. Let's upgrade the second ability. Try upgrading it multiple times to verify it cannot go beyond the max level. Explore the abilities again. You should see that the second ability is still active and its level is now 3. Now let's check how prerequisite validation works. Go to the Save Game folder and delete the player skill tree file. Run the game and verify that no skill tree abilities are granted. Open the skill tree menu and try unlocking an ability. You shouldn't be able to, because there are no skill points available. This confirms that the skill points cost is verified. Add some skill points using the debug key you assigned earlier. Now try to unlock the second ability. You shouldn't be able to unlock it because the first ability must be unlocked first. Once you unlock the first ability, you'll be able to unlock the second one. This confirms that prerequisites work as intended. And that wraps up today's episode of the RPG Framework series. You've just laid the foundation for a fully modular skill tree system, complete with data-driven logic, save support, and integration with the gameplay ability system. In the next video, we'll take it further, implementing custom unlock conditions. If you found this helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss the next step in building your RPG. Special thanks for my Patreon supporters. Thanks for watching and see you in next one.